Hello friends, myself Rajendra Mahajan presenting my video on half-range Fourier cosine series. Uh, Example, find half-range cosine series for the function f of x is equals to there are two values. The first one is 1 by 4 minus x in the interval 0 less than x less than or equals to 1 by 2, and the second value is x minus 3 by 4 between the range 1 by 2 less than x less than or equal to x less than or equals to 1. Therefore, the total range is between 0 to 1. And then comparing that range with that half range 0 to L, we get the value of L as 1. Watch the video up to end for clear understanding, better understanding. Here we require to find half range cosine series given by formula is f of x is equals to a0 by 2 plus summation of an cos n pi x divided by L, capital L. N changes from 1 to infinity, and we call this as equation number 1. Where we have to obtain the values of a0 and an. a0 is given by formula is 2 by L integration from 0 to L of f of x, its integration with respect to x. Substituting the value, we get 2 by L is 1, integration from 0 to 1 f of x dx. In next step, we split it as per the given information. Therefore, it is from 0 to 1 by 2. Fx is 1 by 4 minus x and its integration with respect to x. 1 by 2 to 1 second integral, and that term is x minus 3 by 4 and its integration with respect to x. 2 as it is 1 by 4 minus x whole square divided by minus 2, limits from 0 to 1 by 2, then plus integration of x minus 3 by 4 is x minus 3 by 4 whole square divided by 2, limit from 1 by 2 to 1. Then substituting the upper and lower limit for the first, we get it is minus 2, but original term is minus 1 by 2. Therefore, though I have written here minus 2, consider it as minus 1 by 2. For upper limit, it is 1 by 4 minus 1 by 2 whole square minus, for lower limit, it is 1 by 4 minus 0 means 1 by 4 whole square plus, again here also 1 by 2 outside, it is 1 minus 3 by 4 whole square minus 1 by 2 minus 3 by 4 whole square. Then simplify it. Therefore, 2 into minus 1 by 2 multiplied by, cross multiply it, it is 2 minus 4 divided by 8 and its square minus 1 by 4 means 1 by 16, 1 by 4 square means 1 by 16, plus 1 by 2, 4 minus 3 divided by 4 whole square minus 4 minus 3 to the 6 divided by 8 whole square Then again simplify it to minus 1 by 2 multiplied by 2 minus 4 is minus 2 by 8 whole square minus 1 by 16 plus 1 by 2 times 4 minus 3 is 1 by 4 whole square minus 2 by 8 whole square. Again simplifying it, it is 2 minus 1 by 2 multiplied by, that is 1 by 4 square means 1 by 16 minus 1 by 16, that term becomes 0, plus 1 by 2 times 1 by 4 square is 1 by 16 minus 1 by 4 whole square. That term also becomes 0. Therefore, 0 minus 0 we get 0. The value of A0 is 0. We call this as equation number 2. Then we have to obtain the value of an. Formula is 2 by L integration from 0 to L f of x into cos n pi x divided by L capital. Substituting the value, we get 2 by 1 integration from 0 to 1 fx we keep as it is into cos of n pi x by L and its integration with respect to x. Then we split that integral as per the given information. 0 to 1 by 2, value of fx is 1 by 4 minus x into cos of n pi x and its integration with respect to x. And the second integral is from 1 by 2 to 1, and the term of f of x is x minus 3 by 4 multiplied by cos n pi x and its integration with respect to x. And for simplicity, we call the first integral as I1 and second one as I2, and this is equation number 3, where I1 is nothing but integral from 0 to 1 by 2 of 1 by 4 minus x multiplied by cos of n pi x and its integration with respect to x. As here a product of two terms of x, we have to integrate it by generalized part. Algebraic must be the first, trigonometric as a second term. Therefore, first term as it is, integration of second term, integration of cos is sine n pi x divided by n pi minus derivative of that first term is minus 1. Integration of sine is minus cos n pi x whole divided by n square pi square. Next term becomes 0. Derivative constant term is 0. And limit from 0 to 1 by 2. Subtracting the upper limit, 1 by 4 minus 1 by 2 sine of n pi by 2, put x as pi by 2, therefore it becomes, x as 1 by 2, therefore it is sine of n pi by 2 divided by n pi. 3 times minus means it is minus cos of n pi by 2 when we put x as 1 by 2 and divided by n square pi square. These two terms for upper limit minus lower limit. Sin 0 is 0 and cos 0 is 1, therefore minus 1 upon n square pi square. Simplifying it further, it is minus 2 by 8 sine of n pi by 2 divided by n pi minus cos n pi by 2 divided by n square pi square, and plus minus minus it becomes plus 1 upon n square pi square, and we call this equation number 4th. I2 as integration from 1 by 2 to 1 of fx is x minus 3 by 4 into cos of n pi x. Its integration with respect to x. Then, as it is a product of two terms of x, we have to integrate it by generalized part. First term is x minus 3 by 4 algebraic, and second term is cos. Therefore, x minus 3 by 4 we consider as first and cos as second, and then applying that generalized part. First term as it is, no change. Integration of cos is sine n pi x whole divided by n pi, then minus derivative of x minus 3 by 4 is 1, and integration of sine is minus cos n pi x whole divided by n square pi square. Next term becomes 0 as derivative of constant term 1 is 0. We stop here and limits from 1 by 2 to 1. Lower limit is 1 by 2, upper limit is 1. Substituting the upper limit, 1 minus 3 by 4 we get first term into sine of n pi. When x is 1 we get sine n pi divided by n pi, minus minus it becomes plus, cos of n pi whole divided by n square pi square. These two terms for the upper limit minus lower limit, x is 1 by 2, therefore 1 by 2 minus 3 by 4 sine of n pi by 2 whole divided by n pi, minus minus plus, cos of n pi by 2 divided by n square pi square. And then we have to simplify it further. Cross multiplying we get 4 minus 3 is, or sin n pi is 0, therefore that term becomes 0, and cos n pi is minus 1 raised to n whole divided by n square pi square, then minus 4 minus 6 divided by 8 into sin n pi by 2 divided by n pi, and minus cos of n pi by 2 divided by n square pi square. Further simplification, further simplified as minus 1 raised to n upon n square pi square, that term as it is, no change. This one is minus 2 by 8 means minus, and that minus it becomes plus 1 by 4 sine of n pi by 2 whole divided by n pi, and minus cos n pi by 2 divided by n square pi square, and we call this as equation number next 5th. Substituting the values of I1 and I2 in equation 3, we get the value of An as value of An as 2 times An is equals to 2 times sum of I1 and I2. Value of I1 is minus 1 by 4 sine of n pi by 2 whole divided by n pi minus cos n pi by 2 divided by n square pi square and plus 1 upon n square pi square. This is the value of I1 plus I2 as minus 1 raised to n divided by n square pi square plus 1 by 4 sine of n pi by 2 divided by n pi and minus cos n pi by 2 divided by n square pi square. A bracket close. Here that minus 1 by 4 cancel with this 1 by 4 sine n pi by 2 upon n pi. Therefore 2 times. Remaining terms are 1 divided by n square pi square, 2 upon n square pi square we take outside. The remaining terms are 1, then minus 1 raised to n and cos 2 times. Therefore it is minus 2 times cos of n pi by 2. This is the value of an, equation number 6. Then, and the value of bn is 0 as it is a sine series. Substituting values of a0, an in equation 1, we get f of x is equals to a0 is 0 by 2 summation from 1 to infinity. The value of an is 2 upon n square pi square in bracket 1 plus minus 1 raised to n minus 2 cos n pi by 2 and into cos of n pi x as a required Fourier series, half range sine series, or the required answer. This is the required half range sine series of that given function. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching.